Hello everyone, my name is Josh Gonzalez, and for today's Pencast I'll be going over a problem from week 2 homework, specifically problem number 8. The problem states, figure example 21.8 shows a standing wave that is oscillating at a frequency f of 0, and this is the wave. The question asks, how many antinodes will there be if the frequency is doubled to 2f of 0? Explain. Okay, to start solving this problem, we'll just start with what we know, which is the frequency is doubled, so it's the new frequency, which we'll call f prime, equals 2f of 0. Distance equals rate times time. Wavelength equals velocity times 1 over the frequency, which is f of 0. And velocity equals wavelength times frequency, which is f of 0. What we don't know is mass, which is not really a part of this problem, or a huge part of this problem, I would say. So this problem, it's not too difficult, just some critical thinking. So they start out by saying that the frequency is doubled. So when we plug that into the wavelength equation, velocity times 1, 2, everything's pretty much going to get halved because of this 1/2. So therefore you could say that wavelength is halved, meaning that there will be 8 waves instead of 4. This affects the amount of nodes and antinodes, since nodes are the points along a wave that remain still showing no amplitude, and antinodes are the opposite, occurring between points of large displacement or maximum amplitude. And since wavelength is halved, the amount of nodes will be doubled, so let's draw that. Okay, not a very good drawing, but I tried. Okay, so what we end up having is 8 waves, and each wave having an antinode, since the antinodes will be right here on each side. So from what we get here is we get 1, 2, 3, 4, 5, 6, 7, 8 antinodes, and from the beginning we only had 1, 2, 3, 4, since it's where maximum amplitude occurs. So the answer is, when frequency is doubled, wavelength is halved, which in turn leads to double the amount of antinodes from 4 to 8 And that's the answer.